we will agree on the first exam, okay? So you told me last time that you prefer it to be in the second week of November. Okay.
Yes.
So, do you mind if it is a Saturday? Because like this, you will not have conflict with other materials.
Yes, no problem.
Can it be in the morning بس يعني at around 9-10 بدل بالليل?
Yeah. Yes, sure. So
Doctor, can you repeat whatever you said about the exam? I just joined in.
okay, I am saying that we want to set a date for the exam, and from last time you said that for you it's better to have it in the second week of November. So we made it. We can make it on the second Saturday of November. So it will be nearly, I think, November 14, maybe. I think.
Yes, مظبوط.
Yes, 14.
Okay. So we agree on this. No problem for Saturday, 14 November.
Okay, will it be on campus or online?
No, it will be online. Okay. And I will give you small questions on what we did until now. So we will just now do another chapter. It will include chapters 1, 2, 3. So one is very simple. One is an introduction. Okay. So it will be in the form of multiple choice, and sometimes you will enter your numerical answer. So this is the type. Small questions that will test your understanding of the material. And maybe some MCQ on general knowledge. It's open book, so you don't have to just to understand the concept. No need to remember anything.
وحيكون model based يعني.
Yeah, it will be model based, yes.
Okay, it sounds good.
Okay. So now we will.
Just a question, Dr.
Yes.
So the problem is that involve numerical values. Are they going to be like the problems we solve in class?
Yes. Okay, and
Okay, thank you.
we will still now we will start today a new chapter. I think it will require maybe 2 or maximum 3 weeks. And in case maybe we will not have all the chapters, let us see what do we do. So at least I want to give you time to study. So for within 2 weeks we will do the material within 2 weeks. Within the material we will do during these weeks will be included for the exam. And even if we don't finish chapter 3, so just you stop the material where we arrive. Okay.
Doctor, and what about the paper?
Yes, concerning the paper, we said before, no, the due date was at the end of October. But if you have a lot of issues, we can postpone it a little bit if you want. So I was planning to start presentations in the first week of November. But since you have an exam during the second week, if you want, just when we finish the exam, and starting from the third week of November, we can start the presentations of papers. In this way, you will have enough time.
لأنه كثير معذورين صراحة يعني كله بذات الويك.
So for the paper, look, you
Can we make it till the end of November?
You prefer to postpone the exam or the paper?
The paper.
Okay. So we postpone the paper for the end of November?
Yes, please.
Yes, end of November is good.
Okay. So the exam...
I have a question for the PowerPoint. How long must it be in the presentation to how much must you talk?
15 minutes per group nearly. Okay, so you will present 15 minutes and we will ask you questions about what you did. So in overall, maybe 20 to 25 minutes per group.
Okay, thank you.
Okay, so now let us start. We still have one problem in chapter 2 before we end this chapter.
Professor, can I just ask one question before you begin?
Yes, sure.
the exam, the midterm is going to be second week of November.
Yes.
And what will be like the material for the exam?
The material is on chapters 1, 2, 3. Today we will finish 2, okay, and we will start 3 today. It will require nearly 2 weeks, so you will be responsible of these 3 chapters.
Okay, and can you give us like exercises or a paper of exercises that we can solve?
Yes,
that will prepare us for the exam better?
Yes, sure.
Thank you.
Okay.
Thank you.
Okay, so let us start now. Do you see my screen?
Yes.
Okay.
Yes.
So we still have to do a problem on thermal insulation. So here we are giving for a building element, we are giving properties of different, if you want, U values. Okay. So here we want to calculate the U value for the glass component, neglecting the frame for 2 cases: a single glazed and a double glazed window with the following dimensions: thickness of glass equal to 5 millimeter, and the conductivity of glass equal to 1.5 watt per meter Kelvin. And so here, what we have here is that we have 2 scenarios to compare: single glazing and double glazing. And you know already, you expect that double glazing is better for insulation, okay? And here we will compute in values, in numerical values, why it will be better, okay? So first, if you have to calculate a U value, what should we do? We should look at our elements. So here, I have a window. What are the constituting elements of the window? I can have, if I have single glazed, if I want to draw it, it will be like this. And it is exposed from the inner and outer side. So I have convection from the inner side and convection from the outer side. Okay, and I have, in between, in the glazing layer, I have the conduction effect. Okay, so here I have convection from the outer side. And they should give you, in order to calculate the U value, they should give you the convective coefficient at the outer surface. Okay, and you have, from the inner side, you have also a convection coefficient, and also it should be given. And inside the glazing, heat is transferred by which phenomena?
Conduction.
Conduction. Very good.
Conduction.
Yes. And in the layer, I have the conduction. Okay. So now, if I want to obtain the U value, I will apply my formula, that 1 over the total U value. If you remember, when we talked about thermal insulation, we did the analogy with electricity. So it's like you calculate resistance. Okay. So here you have, in this case, 1 over U is equal to 1 over H1, which is the convection from the outer side, okay? Plus, you know that for conduction, okay, U of conduction is K over D. So 1 over U conduction will be the thickness of the glass over the conductivity, okay, plus 1 over H inner. This is for the case of single glazing. Now, what will change when we have double glazing? When we have double glazing, then here we should add a layer, another layer of glazing here. And when we have double layer, okay, what do we put between the two layers of glass? Do you know, in general, what do we do when we have double glazing? We have a certain air gap.
A space.
Yes, we have a
Air gap.
certain air gap between them. Okay, so when we have, so now we will have an air gap in between, plus a second layer of glass, which will enhance a lot the insulation effect. Okay, so we can write that if you want now the overall resistance of this new system is equal to 1 over the overall U coefficient, okay? It's equal to 1 over HO. So for the outer convection, it will not be affected. It's the same term. It's 1 over HO. But now for the conduction here, we have to divide the resistance into several parts. So we have the resistance in the first glazing layer. We have the resistance due to conduction in the air gap. And we have also the third one is for the second glass layer. Okay, so now we will add plus, since we have here the same, if you want the same thickness for the two glass layers, we can do 2 times, okay, because they have same properties, same conductivity and same thickness. So this is 2 times thickness of the glass layer over conductivity of glass, okay? And now to account for the resistance in the air gap, you will add to this the thickness of air gap over the conductivity of air gap, okay? And now you can see that the resistance here for the double glazing will be higher than for the single glazing. This is why the U value of double glazing is smaller than U value of single glazing. Okay, so we deduce that U value of double glazing is smaller than U value. And in general, when you want to have insulation, you should choose a material of low U value and high resistance. Okay, since you know that the heat flow rate through a certain material is UA delta T. So if you want to reduce the heat loss, you want to reduce the U value. So it's smaller than U value of single glaze. Okay, so this is a small problem on thermal insulation. Any question on this?
No question.
Okay, guys, please, concerning the recording, I am reading what you are asking in the chat. Concerning the sessions, please try to download them directly or within 1 week, because the WeTransfer sessions will expire in 1 week. Now I will repost them for you, but in general, when we post a certain material, just do it directly. Okay. Any question on this? Okay, so this is for chapter 2. Okay, now we will start today a new chapter, which is chapter 3. In this chapter, we will deal with power plants. Okay, so we will learn how power plants work, how we can calculate their efficiency, and also we will look at gas turbines. So you know that the main purpose of this course is to understand how energy can be converted from one mode to the other. Okay, and we will see a lot of devices that will be used to transfer energy in a proper way. And steam power plants are widely used and are very important. This is why we will go over their cycles and understand what were the improvements done on steam power plants, how they improved with time, and what are the restrictions that we have in their design. Okay? But before starting with the idea of steam power plants, I want to do a small introduction for some laws of thermodynamics because you will need them to solve for steam power plants. So to begin with, we will define what is the first law of thermodynamics. So you know that in thermodynamics, okay, we will introduce some new concepts in this session. Already maybe some of you know them, but because I have students from different backgrounds, I will go over a little review on thermodynamics. Okay, so in the study of thermodynamics, it's convenient to consider the bulk kinetic and potential energy separately, and then to consider all the other energy of the controlled mass in a single property that we call internal energy, and for which the symbol is U. But I want to tell you that in general, in school, for example, you have considered for a certain body, you have talked about kinetic energy, you have talked about potential energy. So you are familiar with these types of energy. Kinetic energy, which is related to velocity, and potential energy, for example, if I take a ball, if I higher its level, then it is gaining potential energy. Okay, so what is a little bit new for you maybe is the internal energy. So the internal energy is in general related to temperature, and it's very important, especially in gases. Okay, because for a rigid body, when you deal with rigid body in general, you consider constant temperatures. So we don't have a lot of change in internal energy. It's negligible compared to change in kinetic and potential energy. This is why when you studied the first step of dynamics in school or in physics, you have seen that for conservation of mechanical energy, I say that kinetic energy plus potential energy equal to constant. Now, when we deal with fluids, okay, we will add another type of energy, which is the internal energy. Okay, and it's related to the state of our fluid, and mainly it will be related to its pressure and temperature. So from now on, when we talk about total energy, we will divide it into 3 parts: internal energy, kinetic energy, and potential energy. And you will see that in the application for particles and rigid bodies before, the main forms of energy were kinetic and potential. But here in this course, you will see that the internal energy is dominant over the other types of energy. So the kinetic and potential energy of the control mass are associated with the coordinate frame that we select and can be specified by the macroscopic parameters of mass, velocity, and elevation. On the other hand, the internal energy U includes all other forms of energy of the control mass and is associated with the thermodynamic state of the system. This is why we correlate them to temperature and pressure. Now, since all terms comprising E are point functions, what we mean by this is that at each point, okay, we can define a certain value for the kinetic energy, for the potential energy, and for the internal energy. We can say that the variation of energy, okay, dE, is equal to the summation of variation of the 3 energy types, which are internal energy, kinetic, and potential. And now The first law of thermodynamics states that for any change of state of my system, I can write the following. And to understand it, I will just give a small example. Okay, let's consider you have, let's say, a tank, and inside you have air. Okay, if you compress air, you expect that its energy will increase or decrease if you compress it. So you have a piston here, and you perform a certain compression action. Okay, so you are putting work on your system. When you put work on your system, the temperature of air will increase. Okay, this is because the work you did will be transformed into another form of energy, which is in heat energy. Okay, so this is why we can say that by conservation of energy, we can write that any variation of energy is performed by or heat or work. Okay, so for example, for air, if I do compression, this compression effect, okay, I can rise the temperature of my air. So my work will be transformed into heat, into internal energy of air, because the temperature of air will increase, and therefore its internal energy will increase. Another way to raise my temperature, to raise my internal energy, I can heat air. Okay, if I heat it, so if I just put fire here, then I am giving heat to my system. Also, the internal energy will raise. So we can say, if you want, that the first law of thermodynamics is a very simple equation that states that energy is conserved, but I can't change it from one form to the other. So I can, if I put heat to my system, its energy will increase. If I put work on my system, its energy will increase. This is why we write the thermodynamic law as following. So here, it states that dE is the variation of energy of my system. So I will put it here. So dE will represent the variation of energy of my system. And as we said before, my energy is divided into three parts: internal, kinetic, and potential. Okay, so it will depend on the case. The variation in energy will be divided into these three. Sometimes the variation only will be in internal energy if the kinetic and potential energies are not changing. And we will see that in general, for fluids, we will deal with the variation in internal energy will be much higher than the variation in kinetic and potential. And this energy, this variation can be due to two factors. Or if I heat my system, so if heat is provided to my system, then I will increase its energy. So this is the heat term. Now, why we put minus W, not plus W? Do you have any idea? Why it's not plus W, for example, here?
وقت يكون في weak done by the system بيكون minus W.
Okay, so what I want to tell you, you should understand the convention you are following. You can write this energy in two ways, this equation in two ways. In some books, you will find they will write that dE is equal to delta of Q plus delta of W, while in other books they will write dE equals to delta Q minus delta W. It seems that we have a contradiction, but we should understand what were the assumption in writing the equation. When we wrote in some books, when we wrote plus delta W, we do an assumption here that work is positive, work is positive when done on the system. Okay, so like here in this example, if I do a pressure on my piston, I am doing a work on my system, so I consider that it's a positive work given to the system. This is in this case I put plus W. Okay, on the other hand, some other books consider that no, I will assume that work is positive when done by the system. So when I do the assumption that work is positive when done by the system, do you hear me?